Okay, this video is going to be for Gen 3 and Gen 4 LS engines, and it is for how to tune for a dry nitrous setup. So some of the things, depending on, no matter what your setup, is going to be the same. So one of the things is we start with power enrichment. At the power enrichment, we are going to want a delay of 0. Now, sorry, this vehicle that I pulled up has already been tuned, so some of this information is going to look a little bit different than what you have on your screen. But you're going to want your delay set to 0, your delay RPM, your delay time. Okay, now for a dry nitrous vehicle, you should have your enrichment rate start at about 1.5. Now, when you are logging and checking your nitrous, you are going to want to see if you get any type of knock retard prior to you reaching the optimal air-fuel ratio that you're commanding. If you do get any type of knock retard, you can up this enrichment ramp rate. The next is the power enrichment TPS setup, throttle position. Just make sure that these match on both tables. And for what we are going to do, or for what I recommend, is as long as you're not in a pickup truck, I recommend dropping it to 30% on both of these tables here. If you are using a window switch, you'll need to reach optimum fuel enrichment about 500 to 700 RPMs before you spray the nitrous. So where that is going to be is under here. So let's say you're spraying nitrous at 4,000. Somewhere in here you want your air-fuel ratio to be what you want it to be prior to the nitrous spraying, so that way when the nitrous hits, you don't have to worry about any type of knock or damage to your motor. If you're doing a throttle-based trigger, again, you need to update both throttle position tables. And you should have the tables the same all the way through in order to prevent possible fuel spikes. If you find that you're entering power enrichment mode during normal driving circumstances or just too early in general, you can change the minimum map here to 85 kPa, and at that point it should allow it to go 100% based on throttle instead. That way it is throttle based, so that way it's not coming on just during normal driving circumstances. Otherwise, you can play with the kPa here and see where the line is for the driving that you're doing, that you find that it is turning on or turning off on you. So now let's say that this vehicle is already tuned, and let's say that it is, let's just do this here. Let's say this is your, now I should have already mentioned this, but when you have a vehicle, you're putting the nitrous on, your tune should already be perfect. So this is a vehicle that is tuned 100%, ready to go, naturally aspirated, and is making the best power. Okay, if you're going to add a 50 shot of nitrous, you need to add 10% fuel. Okay, so you need to times this by 10%. You're going to add 100 shot, 15%, 150 shot, 20%, and a 200 shot, 25%. Now, that is for testing. Now, as you're testing the nitrous, you can back the fuel off and lower RPMs prior to the nitrous slowly until it is exactly where your desired fuel needs to be without making it super rich down low. Make sure that you change both ratio tables on vehicles that have an EQ ratio gas and an EQ ratio for alcohol. You'll want to change both those tables just in case. A lot of these cars sometimes will end up in one table or the other, even if you don't even have ethanol. So from there, and I don't even need to show you the Gen 3 and Gen 4. This setup is going to be the same. From there, you're going to want to go to your spark. Now your spark, your high octane and your low octane table should match each other. So one of the things that we do is we select this from right around 60 and about 2400 RPMs. This typically is your wide open throttle box, your wide open throttle area. Most vehicles, when you go wide open throttle through here, they get right around this area before they plateau and come over, which is why you can see that a lot of these numbers are matching, or they basically are identical all the way down. This is going to be the danger area of the nitrous, or the power area. So typically for a car, you're going to want to make this about 12 degrees or so for a 50 shot, and even less, maybe around 10 for a 100 shot or more. And for a truck, it's going to be even less. A lot of weight, a lot of load, you're going to need less timing. So for a truck, you're going to want to be roughly 10 here for a 50 shot and about 5 to 7 for 100 or higher. So if it's, let's say, for a car, you're going to make this whole area 12. From here, this is basically for testing. So this is what you put your base at. Now, when you go out and you test your nitrous, from there you can start adding timing back in to find where the line is of how much timing is too much. Obviously, you don't want too little timing, but we don't want to go out on your first run and have 20 degrees right here and completely blow your motor all the way down the highway. From here, the next point, whether you have a window switch or whether you have some sort of a throttle switch, is to do your testing. So we will make a separate video for the testing for running the nitrous, but this essentially is how you set up to start running the nitrous. Now you're going to want to copy this whole table, and you're going to want to move it over to the low octane table as well. And that's basically it for setting it up for dry nitrous. The hard part from here is doing all the logging to make sure you're not running too much fuel, too little fuel, too much timing, not enough timing. We'll have other videos posted on how to do the logging for that, like setting up your wideband and whatnot.